Hey there, this is Boaz. I'm trying to record directly from Zoom here, so um kind of learning how to do this. Been learning how to share my screen and just like a normal Zoom call, but never recording here. I'm here at Nyland. This is my nice view out my window here. I'm at a co-housing community in Lafayette, Colorado. And yeah, I want to let me share my screen here. Okay. Right. So that happened. So I wanted to share this painting that I think I did this in the last couple days. So here I've got this expression for the action, the integral of the Lagrangian. This was in quantum field theory. And this is something I got directly out of a paper by the paper by Sean Carroll. So that paper is right here, I believe. No, that's not it. Is right here. There's the expression. That's on page 10. So the quantum field theory on which the everyday world supervenes by Sean Carroll from 2021. And just to show that formula again, the core core theory, and he also references Wilczek, Frank Wilczek, and I've just got that audio book of his. So anyway, I've been thinking about, so to go back to the painting, so yeah, this is kind of the quantum field theory that's supposed to cover everything, all of our everyday life. And so that's kind of amazing. Um, so it's an amazing claim and kind of gets at the heart of these questions we have about what are we? What are we made of? What is this world made of? Um, and So is this it? Is this is what we're made of? This R's and G's and F mu news. F mu nu is electromagnetic field. It's kind of like you. This shows up in a one way of writing Maxwell's equations. Um, Psi bar is the electron, the wave function for the electron. Um, and then these are like the free fields, F mu nu, the D mu, I think has a coupling between the electron and the electromagnetic field. And then you've got these Higgs bosons. And then you've got the weak interaction, the not totally sure. Where's the strong interaction in here? Anyway, so all right. So I was just thinking about, does this really include everything? Is this us? So I wrote, "You are here," and I did some abstract painting. I put some nice colors in and just kind of created a colorful thing to look at. I guess I like working with the water. I put the colors in and it blends in the water, and then so it's kind of like these are natural processes here in the world. And so somehow, in the midst of all of this, you are here too. So I've been thinking about these questions of reductionism for a long time. I have two other papers I referenced on Blue Sky, and that I've been thinking about. I mean, I didn't try very hard. I kind of just wanted to get back to this question. Um, so here's this paper, and so here's a paper by Antonino Drago from 2020, and he's talking about reduction between uh, chemistry and quantum mechanics. can you do that? We're often say that you can. I mean, this is a big piece of how you learn chemistry. You've got a chemical reaction, and you say you write down these Hamiltonians, and you often do use quantum mechanics. So there's obviously a very intimate, strong connection between chemistry and quantum mechanics, but can you actually reduce chemistry to quantum mechanics? I guess that's a more detailed question, and you have to be more specific about what you mean by reduction. So this is a paper trying to go through some of this history. Nagel is mentioned, and Faribault, and anyway, gives some detailed explanation. He gives a couple different types of definitions of reduction. I haven't read this very carefully, so I'm not going to be able to give a great explanation here. These are 4 types of reductions that he comes up with, and then basically says, given these, no chemistry cannot be reduced to quantum mechanics. But all right, so what does that really mean? We want to understand that still a little bit better. But here's another paper by Padmanabhan, 2018, and he talks about obtaining the non-relativistic quantum mechanics from quantum field theory. So this is kind of a how do you reduce our normal picture of non-relativistic quantum mechanics from quantum field theory? Because the core model I put there in my painting, this is a quantum field theory. I mean, so when you claim that everything comes from it, what do we really mean by this? What? So I specify. I mean, one way, what Carroll says is this describes the amplitude for going from one field configuration to another field configuration. Okay. I mean, I guess it's the action associated with a path in some sense. Anyway, a path. So that picture of field theory where you have wave functionals and you have one set of fields, and then you want to know what's the likelihood, what's the probability of going to another set of field configuration. So in this paper, he's talking about how do you go from that quantum field theory to our non-relativistic quantum mechanics. And it's quite a detailed paper. And again, I actually haven't read this in great detail, but he's going through, does the emperor have clothes? He's going through the way you might normally try to do it, the standard way of describing non-relativistic quantum mechanics and the standard way of describing quantum field theory, or several different versions. I guess there's operator version and path integral version and such. And he outlines some various challenges with that. And so he runs into some problems, but I wanted to just emphasize something here at the end. So, I mean, basically his conclusion is that you need to reformulate non-relativistic quantum mechanics in a slightly different form to do this reduction, more the operator form where it's more similar to it. Okay, I wanted to read this paragraph here. To conclude this summary, I will comment briefly on 2 issues, which are indirectly related to the discussion in this paper. The first comment has to do with the philosophical interpretation of the wave function in non-relativistic quantum mechanics, which is still strongly debated. But note that one, the quantum field theory is more fundamental than non-relativistic quantum mechanics, and two, we do not have a sensible notion of single particle wave function in relativistic quantum mechanics. Therefore, the debate over the ontological versus epistemological status of the wave function within the context of non-relativistic quantum mechanics, in which it is often attempted, seems irrelevant and misplaced. At the least, one should escalate the debate to full quantum field theory, say in Schrödinger functional formalism, for it to be meaningful. But then we will face several new serious, non-trivial issues which might take precedence and change the nature of the debate. The second comment is more technical. All right, I'm not going to mention the second one. I just wanted to to point out this first point here and just get started on this topic here. Yeah, that's kind of what I'm looking at today, and was just trying to learn how to make videos like this, and um, maybe maybe I'll be able to get better at doing this and present present my ideas in a more in an entertaining way, but that brings people into these discussions that really interest me, that I've been focusing on. Thanks for watching.